Hello and welcome. Today, we are diving into the world of spec-driven development, and specifically, we'll be looking at how GitHub Spec-Kit can streamline your workflow and ensure your projects are built exactly as intended. We'll begin from the terminal and initialize the project, then move step by step as the AI shapes the entire structure, from specifications to implementation. I start by running the command to initialize Spec-Kit. During setup, I select Cursor AI IDE as my development environment. Once done, I open Cursor and the workspace is ready. Spec-Kit automatically generates the foundational documents for the project. You'll see files like plan.md, specify.md, task.md, and several others, all structured to drive the workflow. These files define what we are going to build, how it will be built, and in what order. Now, I begin by selecting the specify command in Cursor's chat interface. For the initial prompt, I type, build an application that can help me create a resume builder called Resume Flow. Spec-Kit processes the prompt and updates all related documents, outlining the initial scope and high-level specifications for the Resume Flow project. Next, I use the constitution command. This updates the constitution.md file with the minimal rules and governance details for the project. The AI creates the specification templates and the bash scripts. I'm running all the commands manually for now. I like to supervise each step and see how the specs evolve. Cursor does let you add them to an allowed list to auto-run next time, but I prefer a bit more control rather than complete automation. New features are being added, and while reading the specs template, the AI creates a comprehensive specification for the Resume Builder application. Typically, this is one of the first steps in a spec-driven workflow. However, in this case, I wanted the system to first understand the project specifications before defining the overall constitution. I asked the AI agent to update the constitution.md file with bare minimum rules and governance details for the specified project. The constitution.md file is updated with the de facto rules required for the project. Then, I move on to the plan command. This step is where Spec-Kit really shines. It generates and updates all the necessary plans, requirements, research notes, quick start guides, contracts, and models. Previously, I used to manually create the PRD, task lists, and agent files using ChatGPT. Now, with Spec-Kit, that entire process is streamlined. While I focus on the core functional requirements, the spec-driven framework handles all the background structure automatically. Once the plan is created and updated, Spec-Kit provides a summary that you can easily review. After careful review, we can either make changes or continue on next phase. With the project plan complete, I now use the task command. The AI creates a comprehensive task list, breaking down the entire development flow into actionable units. Each task is aligned with the specifications and ensures that implementation stays consistent with the defined goals. After all tasks are generated, they move into the review phase. This is where you validate each requirement and confirm alignment with the intended specifications. The AI is designed to ask for clarification whenever ambiguity arises, ensuring consistency. Still, manual review remains crucial. It helps catch any assumptions or additions the AI might have made during interpretation. The planning phase is complete, and we now have a clear summary of everything the AI has outlined. Finally, I execute the implement command. Here, Spec-Kit follows a test-driven development (TDDZ) approach, ideal for structured, reliable code generation. It automatically scaffolds both the front-end and back-end source code, precisely following the specifications we've defined. Once a phase is complete, it sometimes asks whether we can continue to next phase. Simply say yes and continue. Next, I integrate a PostgreSQL Docker container and update the .nb file with the required variables. To make it easy to rerun and maintain the project, I also create a RUN.md file, which keeps all the necessary startup and management commands in one place. Next, I integrate a PostgreSQL Docker container and update the .nb file with the required variables. To make it easy to rerun and maintain the project, I also create a RUN.md file which keeps all the necessary startup and management commands in one place. With that, the system setup is complete. Now, let's look at the final result, the Resume Builder application. Here's the landing page, providing a clean entry point for users. And here's the builder interface, where the live preview updates instantly as users fill in their details. It's simple, fast, and visually clear, all built entirely through a spec-driven workflow. This project shows how spec-driven development creates a structured and reliable bridge between human intent and AI execution. Every feature, from the planning documents to the code, follows a clear specification, ensuring predictability and consistency. In a future video, I'll be covering OpenSpec, a framework inspired by Spec Kit, but designed to manage evolving, multi-phase projects with even greater flexibility. Thanks for watching. If you'd like to see how OpenSpec extends this workflow, stay tuned for the next video.